Hi, I'm Kel Rooks, the physics geek from Seattle. I think you know the drill. I'm going to address this video here to the folks at NOAA, Dr. Al Bedard, and the only other name I can name is Holly Palm, and I thank you for all your conversations with me, Holly. I see there's quite a number of people interested in what I'm doing here, from the number of views on my linked videos, closed link videos, and indeed we are on the moment of something I believe historic, a new theory, and finally understanding the causes of what's causing all our whirlwinds in this world in a new way, and a way that's going to allow us to indeed grapple with some of them in very viable ways, which I've already expressed and sent many emails about. The last video that I had to you was kind of chopped for time there, and it was a little bit rough because of my cough. Hopefully today that's not going to present itself so much. But I wanted to go back to where I was working on three forces that do cause material to spin in a vortex as it is forced through a drain. And I identified the first one as friction. Actually, that has to be coupled, of course, with gravity. It's the idea that I had back in high school that was mine alone. It wasn't something the teacher presented or anything, but not something I got really vocal about at the time. But I think probably we must have been discussing the angular momentum property of it. And I came up with this other because I thought, well, even when it drains still, or relatively still, it still starts to spin. And I guess that's just something that got overlooked over the years as far as I can understand it. But we were going over the angular momentum part, and I did say that the angular momentum doubled when, or not the angular momentum, but the speed doubled when the radius was taken down to half. And actually the angular speed goes by 4, which I noted in the written material I sent. And of course that is r squared. So these forces are really incredible when that starts happening. Is that if you could cut the radius then in a quarter, then your angular speed would jet to like 16 times what it was originally. And if you could even cut it down to 1/8, which would take a considerable amount of force, then you would go to 256 times your original speed. So you are putting it into an accelerator there that is very, very incredible. The gravity part of it, though, or the pressure part of it, as it translates to in wind vortexes, is a pretty important part, and I'm afraid I'm going to have to put it in the driver's seat. It is, if you stop to think about gravity, just for some basics, or what kind of force are we considering with that? It is not any, small force. We're talking about something that if you fall, it hurts. We're talking about 10 meters per second approximately, and virtually all that force, 100%, except what may be turned into heat through friction, is turning into rotational spiraling energy in a drain. So you're getting something that in 15 seconds, if it weren't for friction, could go roughly, very, very roughly, in a neighborhood of 300 miles an hour. So what is happening there is you're getting a combination of those forces, and you're getting something where it develops and turns everything around it into its favor, into a virtual closed system. You're getting a thing where the angular momentum wind that's there, that started there, is getting, you know, broken off because he can't keep up with that speed. It becomes trailers, and those then add in. You don't really lose them, I don't think. You just get them coming in a little bit later after they're whipped up into shape. It's kind of like, I kind of compare it to a taper, although it's very, very different, of course. But if you've ever seen professional tapers, they can do a corner without any lines and stuff and just make it look pretty by the time they get the second or third coat. And they just, if you watch them, and I'm a taper, you know, hey, I leave lines. But these guys, you know, they quickly whip the whole surrounding area into the perfect shape of when they take that final stroke with that taping knife. It just smooths it out completely. It's good all the way to the corner to the outside edge. And it's pretty phenomenal to watch somebody. They got the hands of a surgeon or whatever, and the eye of, I don't know what, an artist. But in a very, very different way, this tornado is doing something similar. It is taking its environment and making it what it wants. It's taking that rotational energy that already is starting to accelerate around it, and that's starting to move all the rest of the air around it to where it's moving slightly, and it's centering itself around what it is, and all of a sudden everything is just going boom like that. You know what I mean? With the gravity and with the angular momentum all coming in. But it's the gravity or the pressure that runs the thing. I mean, just put it this way. If you had, the drain is a device that makes the whirlwind or the vortex of any kind. It is the drain, okay? If you didn't have a force that was pushing it through the drain, just say you could just turn up a drain here sideways a minute so we can take a good look at it, okay? I had a little thing here to show you guys. I don't know where is it, but I don't know where it is. I had a little circle on a paper with bent vectors. Here it is. Woo! Okay, just so you can see, you're gonna have to go backwards here a minute. But I'm gonna, okay, this should be about right. Wind coming in from the side, and it starts all this thing. But then, you know, you get, here's the tornado and the bent angular momentum of the wind circulating around it, which then goes in and creates more speed and all that. So where was it? Okay, okay, we were, oh yeah, the thing at the side. Okay, so we're going to turn out this drain right like that. Okay, and if you had a big bunch of fluid here and some other fluid here, maybe it was colder or something or whatever, but we just had a piece of sheet metal for the barrier's sake. Hey, whatever you want to look at it like. And it was just two-dimensional practically, okay? Now if it's just there, that hole's not going to cause a vortex. You're going to have the force pushing it through there. Once you push it through there, then it becomes, this vortex. It starts spinning. I kind of have some questions still a little bit in my mind about whether the gravitational thing needs a pipe. The angular momentum doesn't. If it was just two-dimensional and it was done and it could just spread out after it gets on the other side, well then, it would still be working. But I don't think, but it's not really a driving force unless you're going to tell me this right-hand rule. If you tell me the right-hand rule can push all that stuff up through there once it gets going, you might have an argument. But the other, just say, let's turn it back like that again, and you got your air going up there and spinning through this thing. It's helpful, I believe, that it has a pipe for the gravitational friction forces, because if it could just disperse up there, I'm not sure what you would get. Fortunately, this thing is turning itself into a pipe all the way to the ground and all the way up through the cold air blanket and stuff, so you don't have any problems with not having a pipe. You might have a pipe that's expanding because it is a soft drain, granted, but it is still, as long as it can still provide the constraint, as long as the pressure is still there, it's going to do that thing that it does, which we don't want it to do so badly. the thing is too, it proves that part of the theory that I've been working with, saying, hey, look, more pressure means more speed, less pressure means less speed. Since we got so many variable wind vortexes, I mean, we got lazy ones that you know, start on the ground, they might be dust devils or slow, whatever, they're fast, whatever, depending on what kind of pressure that you have. And angular momentum actually becomes the servant force. It's dependent, I believe, on the gravity or pressure that's driving the material through the drain. Okay? And if you, so I mean, we got vortexes, as I've explained, and I'm sure as already was known about, for instance, a thunderhead being formed from vortexes. You got what, in my opinion, would be a medium speed, probably, but very powerful vortex that's going up through there, and it doesn't have enough speed or whatever, moxie, to hit the ground, but it sure has enough to keep on going through the cold barrier. And when it's up through that, it's not done. It keeps on bringing more material, piling it around, as you can see from the top, and just climbing up through that and doing more and more until you get this thing that's 40,000 feet high or whatever. So, and then you get 3 of those, and I guess you got a supercell or something, and then you got real trouble, as we know. And I've spoken a lot about those, written a lot about those, and I think I got some good ideas and good concepts that are going there. But I hope you're seeing at this point how just the fact that there's a drain being formed, a constraint of a drain, soft drain as it is, you know, hot air starts to rise through a leak, it starts doing this number, and all of a sudden you got, you know, angular momentum, gravity forces that are converting into pressure forces, and can obviously be quite great, accelerating a wind vortex that becomes a tornado with all the speed that a tornado has. So